Let us look at the partial derivatives of these functions here. First of all, remember, when you have partial derivatives, you have more than one letters or symbols. And what you do is differentiate the function, treating one of those letters as the variable and all other letters as if they're just numbers. Alright? So, example, let's look at this. We have z is equal to 2y. Now I put a line across my z because sometimes when I write z, especially when I'm writing a bit fast, it kind of look like 2. So I want to distinguish my z or z, some people would say, my z from 2. Alright, now, I mean, here in this case we have z equal to y. Now, suppose we want to find, well, we would have termed it before as the derivative of z with respect to x. That's how we write dz by dx, right? Derivative of z with respect to x. But when it comes to partial derivatives, we can say d with small z, or what we do is use this symbol, right? Delta. This is delta z by delta x. I'll just call this partial. The partial derivative of z with respect to x. Sometimes we might use the word partial. The partial of z with respect to x, meaning the same thing as the partial derivative of. Alright? So the partial of z with respect to x, what do you think it would be here? Well, in this case, even though you see y, the letter y, you're treating it as if it's just a number. So this would be like you have z equals 2y plus x to the 0. No, it's 2y times x to the 0. Sorry about that, my mistake. It's like 2y times x to the 0, right? Because the fact is 2y means the same thing as 2y times 1. And the thing is, x to the 0 is equal to 1. So using the power rule, you multiply by the 0 here. So what you get is 0 times 2y times x to the 0 minus 1. Remember the power rule. So it's 0 times 2 by y times x to the negative 1. But the fact that you have all of this multiplied by 0, all of this would be amount to 0. So dz by dx would be 0. You see that? Alright. Now, you tell me, suppose we find dz by dy, what will it be? Or, not d. I said dz by dx and dz by dy. It's really delta z by delta y, which I will call the partial of z with respect to y. Right, the partial derivative of z with respect to y. What would this be? Well, this is saying z is equal to 2y. It's 2y to the 1. So you remember the power rule? You have to remember these things, you know. You multiply by 1 is 1 times 2y to the 1 minus 1, which in this case will give you 2y to the 0. But y to the 0 is 1. So it's 2 by 1. So what you have is 2. Alright? You see that? So the partial derivative of z with respect to y would be 2. It would be similar to when you had y equal 2x, and you say dy by dx equal 2. You remember that? Alright. Suppose we look at the second one now. Alright, this one. We want the partial derivative of z with respect to x. It would be, in this case, using the same argument, it would be 2. But what would be the partial derivative of x with respect to y? Right? It would be, well, in this case, all of this would be just a number. So it would be all of this by y to the 0. And then you use the power rule and multiply all of this by 0, just as we looked at before. So it would amount to 0. See that? But now, what about this one? Z is equal to xy, and we want the partial derivative of z with respect to x. Well, let's argue it out. Partial derivative of x with respect to x. I mean of z with respect to x. If you write the power of x, it will be x to the 0. I mean x to the 1, right? Which is x times y. Then you use the power rule on it. You multiply by 1. Put the 1 down here. So you have 1 times x to the 1 minus 1. It would be 1 times x to the 0 times y. And then, of course, x to the 0 is 1. So it's 1y. But 1 times y is y. So it's just y. You see that? So the partial of z with respect to x is really y. Now what do you think the partial of z with respect to y would be? Well, using the same argument, right, you would consider in the power rule the power of y. It would be 1. And you multiply by 1. So you bring down the 1 in front, and here you reduce the power of y by 1. So it's y to the 0. So when you have y to the 0, it's 1. So it's 1 times x. So using those arguments, what you have is that the partial of z with respect to y would be x. So that's what you have there.